All right, so now we're still doing some of the homework problems from the section that starts on 308. We're doing some of these problems from 43 to 60 really quickly. They're all pretty easy, you know, as long as we follow the pattern for finding the inverse. So just to kind of remind you of what that looks like. First, what we do is we change f of x. We just change it to a y. Okay, and then the second step, we change all the y's to x's and all the x's to y's. And then the third step that we do is just solve for y. Get y all by itself on one side, so y equals. That's what we're looking for at the very end. Okay, so I'll just do a couple of these real quick. I'll do number 45, I guess. So 45, just follow that same pattern. So I start with f of x is equal to negative 3x plus 2. Okay, so let's find the inverse function, because it looks like we have to find the inverse and then check the answer, so we're going to plug it back in and see that we get x, and then find the domain and range for both functions. Well, for the original function, that's pretty easy. The domain, since it's a linear equation, is going to be all real numbers, and then the range, if we graph it out, we'll also see that it goes in each direction, up and down, for the entirety of the graph. Now let's find the inverse function, so that's the domain and range for that. For the inverse function, we change the f of x to a y, so y equals negative 3x plus 2. We change all the y's to x's and the x's to y's, so the second step, this becomes x is equal to negative 3y plus 2. And then the last step, solve for y. So I want to get y all by itself, so I'm going to subtract 2 for both sides. X minus 2 equals negative 3y, and then divide both sides by negative 3, so x minus 2 over negative 3 is equal to y. Okay, there's my inverse function. I'm just going to change up the notation now so that it writes out, nicely in function notation. F inverse, or in other words, f to the negative 1. That's the symbol for inverse of f. Okay, so that's our function. Now, here's the nice thing about it. If you know that it's 1-to-1 and a function, then the inverse and the original function just have opposite domains and range. So if the domain is all real numbers for the original function, that means that the range on this one is going to be all real numbers. So whatever this one is going to be the same as this one, and then the range is all real numbers, so that means that the domain of the inverse is going to be all real numbers. So that's pretty easy, not terribly difficult. And then let's prove that we have a function and its inverse here by doing a composition. So we're going to do f of f inverse of x. So we're just going to plug this whole function in for the x value over here, or any x value that you see in the original function. So we get the following. So here's our template of f. It's negative 3 times blank plus 2. And in that blank goes the inverse function. So x minus 2 over negative 3. So this is pretty nice because the negative 3 multiplies in and it gets rid of that divide by negative 3. So they basically cancel out. And I'm left with x minus 2 plus 2. And then negative 2 plus 2 gives me 0. So I'm just left with x. And that's what we should get when we have an inverse function. Okay, so that was number 45. I'll pick another kind of random one. I guess 48, sure, 48. So for number 48, our function now is x to the third minus 1. So if we were to graph that out on our calculators, let me find my little graphing calculator, there it is. What do we get? So y equals x to the third minus 1. And make sure I've got our nice grid there. There we go. Okay, so there's our function. So all of the x values are going to be accounted for here because there's no domain restrictions, because it's a quadratic, or not quadratic, but a cubic. And then the range, if you notice, like the y values will continue to go down, the x values, the y values will continue to go down and up. So that means that we have all real numbers for the range as well. All right, now let's find the inverse function. So we follow the same pattern. So change the f of x to a y, so y equals x to the third minus 1. Change the x's to y's, the y's to x's, so x is equal to y to the third minus 1. Now solve for y. So I'm going to add 1 to both sides. X plus 1 is equal to y to the third. And then I'm going to get rid of that third power by taking the cube root. So I take the cube root of both sides, and I get the cube root of x plus 1 is equal to y. And since these aren't even powers or an even index, that means that we don't have to worry about the plus or minus out front. So this is the inverse function. I'm just going to change my notation to reflect that. F inverse of x. There we go. There's my inverse function. And also, since this is a function and also one-to-one, that means I can just switch these two around. So that means that my new domain is going to be the old one's range, which is all real numbers. And then the new range for this is going to be the same as the domain of the old one, which is, again, all real numbers. So nothing really particularly crazy about that one, number 48. Let's do, I guess, I don't know, one more. Let's see here. Let's do, I guess we haven't done one of these ones with the inequalities. Let's do 53. So for number 53, my function is f of x equals x plus, quantity x plus 2 squared minus 3. So x plus 2 squared minus 3. And this is really important because it tells us that x has to be greater than or equal to negative 2. And you know what that is right there? That's the domain. It tells us all the x values that we can possibly use. So I'm going to graph this out with my calculator, and then using my domain, I'm going to take a look and see what the range is going to be for this whole thing. So quantity x plus 2 to the second power, and then minus 3, and then graph it out. All right, cool. So I know that it's supposed to start at x is greater than or equal to negative 2. So if I just use my calculator and just kind of follow along, negative 2 is going to be where the vertex is. And we should have estimated that based off of the fact that, you know, if you remember vertex form, this is the vertex, negative 2, negative 3. So that's the low point there. So that means that it's going to be constantly positive on our graph. And it also tells us that since the vertex is going to be at negative 2, negative 3, and that means that it's just the graph's going to go from negative 3 to positive infinity. So for our range, the y values are going to be greater than or equal to negative 3, just because it keeps going up on our graph, you know, to positive infinity for the y values. Okay, so as you can probably guess, you know, later down the line when we have to do the domain and the range for the inverse function, since we already know the domain and the range for this stuff, we just have to switch them around over here. So like, the domain for the x values becomes the range for the y values. So if it's x is greater than or equal to negative 2, that means that the range down here is going to be y is greater than or equal to negative 2. And then for this one, since the range y is greater than or equal to negative 3, that becomes the domain for our inverse. So x is going to be greater than or equal to negative 3. Isn't that neat how they just kind of switch? And it all comes from the fact that, you know, with inverse functions, with inverse functions, the x values and the y values just switch. So the domain becomes the range becomes the domain. Same kind of idea as that. All right, so let's go through the step-by-step process to get our inverse functions. So f of x turns to y, so y is equal to the quantity x plus 2 squared minus 3. And then change the x's to y's, the y's to x's, so y plus 2 squared minus 3. And then solve for y. So I'm going to add 3 to both sides. X plus 3 is equal to the quantity y plus 2 squared. Now I'm going to get rid of that square by taking the square root of both sides. So I get the square root of x plus 3 is equal to, and then I've got y plus 2. Now, when we took the square root of this part over here, you've got to kind of remember that you have to account for, well, you know, we'll just see what the graph looks like, okay? Because I was going to say something about the plus or minus values, but let's go ahead and just see how the graph looks, and then we'll kind of make a determination on that. But let's put a plus or minus there for now, and then put a little question mark next to it, because we're going to see if we actually need that plus or minus in a little bit. So to get the y value by itself, we subtract 2, so that ends up with negative 2, and then that plus or minus maybe, square root of x plus 3 equals y. So check this out. Remember our domain and range that we predicted over here? Well, this x value being greater than or equal to negative 3, if you look over here, remember that if it's in the radical, we need to say that x plus whatever's inside the radical needs to be greater than or equal to 0 if it's in a radical. So we solve for x is greater than or equal to negative 3. See, it's the same exact domain as we predicted. Now, for the range, what's going to happen is that if we were to graph this out, the negative part of this that we're looking for here. All right, so let's put the positive and the negative on here. And also we got to remember that this is just going to be graphing this part and reflecting it over the line y equals x. So I'm going to just put the positive part in there first. Well, actually, no, let's do both colors. Okay, so I'll do it on different lines. So the first one's going to be negative 2 plus the square root of x plus 3. So negative 2 plus the square root of x plus 3. Where are we? X plus 3. There we go. And then on a different graph, so now it's going to have a different color. I'm going to do negative 2 minus the square root of x plus 3. So x plus 3. There we go. Graph it all out. Let's see how it looks. So there's the other graph and the negative graph. So if you just, so this is the cool part about it. If you just did the x values on this graph from negative 2 up, it looked like that. And then the red one that we have, the positive one, is only going to be this guy right over here. So it's going to be helpful for you to graph this stuff out, but remember that since we're only dealing with half of the blue graph, we only have to deal with this top one right here, this red one right over here. If it was the opposite, like if the x values we use were only like less than or equal to negative 2, we'd use this part of the graph, and we'd use the negative 2 minus square root of x plus 3 instead. So pretty neat stuff, right? So what that tells us is, in other words, that we don't have to account for plus or minus. We are only going to be using the positive value for our inverse. So that's f inverse of x. There we go. So, when in doubt, graph your stuff out. Make sure that it reflects over the line y equals x. Let's verify that as well. Let me get rid of that negative one right there and clear that out and just put an x instead. And okay, so there it is. Imagine that half of the graph is gone. And then there's our reflection over the line y equals x for the inverse. There we go. So yeah, pretty neat stuff, right? I think that's about it. Yeah, let's that'll be it. Because I know that you guys have like maybe one more problem in here, but let's call it a day for the graphing stuff. All right, so that's about it. And if you still have questions, don't forget to send an email or sign up for ACLab or something like that. All right, have a nice day.